All right, here is some extra factoring by grouping practice. All right, it does take a little bit extra time to completely feel comfortable with this skill, but once you do, it will come as naturally as other types of factoring. So for example, here you have 12a to the third minus 9a squared plus 4a minus 3. The sign that you need to factor by grouping is that I can't divide any of this, all four terms, by the same number. Okay, I can't divide it all by 3 because I can't divide 4 by 3. I can't divide it all by a because the 3 has no a. So there's nothing I can take out. There's nothing, and I want it to have 3 terms if I was to just put it into 2 polynomials, right? Okay, so, sorry, 2 binomials, which is a polynomial. Anyway, all right, so you group them. When you're creating your groups, it doesn't matter if when you're deciding whether the -9 goes first or the 4 goes first, you can put the 4 with the 12 and you can put the -9 with the -3. It does not matter the order in which you put the 4 numbers, okay? So here's our groups. Our first group is 12a to the third minus 9a squared. If I just look at the 12 and the 9, the entire term, I know that I can divide them both by 3 and get a whole number, right? 12 divided by 3 is 4, 9 divided by 3 is 3. I also see that it has 3 a's and this has 2 a's, so I can divide it all by 3a squared because it's common to both of them, okay? So a 3a squared is common to both of them because I can divide both of them by 3a squared and be left with a whole number term, okay? So that means what I'm doing is I'm essentially taking out 3a squared. Okay, I have 12a to the third. I'm going to divide it by 3a squared, and what I get is 12 divided by 3 is 4. A to the third divided by a squared is just 1a left over, right? -9a squared, -9 divided by 3 is going to be a -3. A squared divided by a squared leaves you with no a's. So you have no a's and you have a -3 because -9 divided by 3 is a -3. Good, you're done with that side. Now come over and look at this. Make sure if it's a plus that anything you pull out, so what we did is we divided and we pulled that out. Anything you pull out is a positive, okay? So we're going to keep it positive because what you want is you want the 4a minus 3 to show up here again, okay? So 4a minus 3, is there anything I can divide them both by and get a whole number? Do 4 and 3 have any common factors? 12 and 9 had the common factor of 3. 4 and -3 don't have any common factors, in fact. Only thing I divide it by is 1. Okay? So now it's a positive 1 because that's a plus 1. If I divide 4a by 1, I just get 4a. And if I divide -3 by 1, I just get -3. What you see now, if you look at this whole thing, right? This is one side. This is the other side. You can even think of them as 2 terms, okay? Let me go back a step 1. All right, here, for example, we have 7a plus 4a, right? What can I pull out of 7a plus 4a? I can pull out an a, right? I can divide them both by a. And then what it's going to look like is that a comes out in front, just like the 3a squared came out in front. A comes out in front, and I'm left with 7 plus 4, because 7a divided by a just leaves me with 7. 4a divided by a just leaves me with 4. So right now I have a times 7a plus 4 instead of 7a plus 4a. They are the same. They have the same equality. There's just, this is the factored form, this is the non-factored form, okay? So that's what we're actually going to do here is we're going to change it from we're just going to factor it once more. So just like these had a in common, these two have 4a minus 3 in common. All right, so these have 4a minus 3. So just like these had a, and so we divided them both by a and put the a out in front. These both have 4a minus 3, so we're dividing them both by 4a minus 3. So when I divide this by 4a minus 3, what I get is 3, right? Just like here, I canceled it, or I divided by 3a squared and pulled that out in front and was left with 4a. Now I'm going to take 3a squared times 4a minus 3, divided by 4a minus 3, and I'm just left with 3a squared, right? Here, 1 times 4a minus 3 divided by 4a minus 3 just leaves me with 1, okay? And then just like we took that 3a squared and put it out in front, now we put, it doesn't matter if it's in front or behind, but we put what we factored out, what we divided in front. Okay? So you're taking each term, saying, what can I pull out? What can I factor out? Putting that in front, writing what you have left over, right? 12a squared divided by 12a to the third divided by 3a squared is 4a. Negative 9a squared divided by 3a squared is negative 3. Over here, there was nothing, so I just said 1, but I luckily got the same term. 4a minus 3 is common to both, so that goes in front, and then I combine these two and multiply by that. If you can check your answer, you can check if you were correct by multiplying that back out. So if I take 4a minus 3 and multiply it by 3a squared plus 1, 4a times 3a squared is going to be 12a to the third. 4a plus 1 is 4a. Negative 3 times 3a squared is negative 9a squared. Negative 3 times positive 1 is negative 3. It's not the same order, but it's the same terms. That. Okay, that's how you know you've done it correctly. Okay, so we'll do it again over here. We're going to group them into two different groups. 2p squared plus, 2p cubed plus 5p squared. My common factor is just going to be, I can divide them both by p squared, right? So I'm going to put that p squared out in front, but I'm factoring out. 2p cubed divided by p squared is just 2p. 5p squared divided by p squared is just a positive 5. Good. I'm going to go over to the other side. I haven't even looked over here. Positive 6p plus 15. Is there anything you can divide both 6p and 15 by? There won't be any p's, right? Because there's no p's in 15. But if I divide 6 by 3 and I divide 15 by 3, I get a whole number both times. So I'm going to pull out a positive 3. That was a plus, so it's going to be a positive 3. 6p divided by 3 is 2p. 15 divided by 3 is just a positive 5. Sorry about that mistake. Okay, now, again, what I have is this entire term, and then I have this entire term. They both have 2p plus 5 in common, so I'm dividing them both by 2p plus 5. 2p plus 5. And then just like I put p squared out in front and then took it out of both of those, I'm going to put the 2p plus 5 in front. I have factored it out and I'm just left with p squared. I have factored it out and I'm just left with plus 3. And since it's two terms, you want to put the parentheses there. Okay. So all that means is multiply. Here, I have 3n cubed minus 4n squared. 3 and 4 don't have any terms in common except 1. N cubed and n squared have n squared in common. Okay, so now I'm going to take n squared out in front. 3n cubed divided by n squared is just 3n. Negative 4n cubed divided by 4n is just negative 4. You know you've done this correctly if you go back and you multiply it and you say 4n squared, or sorry, n squared times 3n squared gives me 3n cubed. N squared times negative 4 gives me negative 4n squared. That is, I've factored it. It's true, right? If I can go back and multiply it through and get my original two terms, I know I've factored it correctly. And remember, you always want to pick the number, the biggest factor you possibly can. All right, over here, positive n squared minus 12. N and 12, just like up here, we can divide them, or sorry, 9 and 12, you can divide them both by a 3. And you have a positive n and a positive 9 and a negative 12. How do you decide whether the 3 should be positive or negative? Whatever this is what you want the 3 to be. So I'm going to say plus 3. If I take 9n divide by 3, I get 3n. If I take negative 12 and divide by 3, I get negative 4. Good. So now, again, I make sure that these terms are the same, and they are, and then I factor it out, right? So I factor out 3n minus 4, 3n minus 4. What I get is n squared plus 3, just by taking the first two terms, times 3n minus 4, what I factored out. And I know I've been switching back and forth. Here I put this term first. Here I put this term second. Or sorry, this term first, this term first. Oh, I've been putting it first. And now I switched and I put it second. It doesn't matter the order you put it in. Okay, you'll get when you multiply it out, you'll get the same number. So you can say I'm factoring out the 3n minus 4, so I'm going to put it in front, or you can say I'm taking n plus 3 and multiplying it by 3n minus 4. Does not matter. Okay. All right, the fourth one. So again, split it into 2. And here I could just show you, well, let's just keep going. 12n cubed plus 4n squared. I can divide them both by 4, right? 4 and 4, because 12 divided by 4 is 3, 4 divided by 4 is 1. 3 n's, here I have 2 n's, so I'm just going to say n squared. It's the biggest n group I can take out. So here is 4n squared. When I take 12n cubed and divide it by 4n squared, I get 3n. And then here, I just say plus 1 because I'm dividing a term by itself, right? Over here, I have 3n plus 1. Nothing is going to be, you can't, right? There's nothing you can factor out of 1. So I'm just going to have to say it's 1. It's a positive 1. 3n plus 1. But that's good because that matches what I already had. So now I'm going to take those, divide by 3n plus 1. Factor that out in front, and I get 3n plus 1 times 4n squared plus 1. Because that was that term and that term. All right, and even if, let me show you here, even if I switched these two numbers, 12n cubed plus 3n plus 4n squared plus 1, okay? And I'm going to do the same thing. Two groups, 12n cubed plus 3n, I can divide them both by 3n. And what I get is 3n times 4n cubed plus 1, right? Over here, 4n squared plus 1, all I can divide it by is 1. So I say plus 1, 4n squared plus 1. I still have that 4n squared plus 1. I'm going to divide them both by 4n squared plus 1. 4n squared plus 1. So that means I have 4n squared plus 1 times 3n plus 1, which are the same two terms I had over here. Good. Okay. Here I have m cubed minus m squared. What I can factor out is 2 of the m's, right? So it's m squared, m minus 1, because it's a negative, because that's a negative, and then m squared divided by m squared just leaves us with 1. Here it's a plus, so I'm just going to write plus. 2m minus 2, I can divide them both by 2, so plus 2. 2m divided by 2 is just m. -2 divided by 2 is just a -1. Good. So now my groups are m minus 1 times m squared plus 2. Here I have 5n cubed minus 10n squared. Divide them both by 5n squared, 5n squared. The 5n squared out in front. 5n cubed divided by 5n squared leaves me with 1n. -10n squared divided by 5n squared is a -2, right? Because -10 divided by 5 is 2, -2. N squared divided by n squared leaves me with no n's. Okay. Over here, I have 3n minus 6. Divide them both by 3. So I have plus 3 is my factored out term. 3n divided by 3 is just n. -6 divided by 3 is -2. Good. So I factored out n minus 2 from both. Put that in front. And what I'm left with is 5n squared plus 3. Number 7 says 35xy minus 5x. I can divide them both by 5x, right? 35 divided by, oops. I am just writing whatever I want. 5x is outside. 35 divided by 5 is 7, right? xy divided by x just leaves us with that y. -5x divided by 5x is a -1. For the other side, it's going to be a minus, so I need to write a negative, okay? So I'm going to take out a negative term. 56y and 8, they are both divisible by 8. So I'm going to divide it by -8, divide it by -8. Remember, I had to make it negative because of this. That's a minus. -56y divided by -8. -56 divided by -8 is 7. Take that y. +8 divided by -8 is a -1. So now I have 7y minus 1 as my common term. When I factor it out of both, I get 5x minus 8 as what I'm left with, and then I multiply it all by 7y minus 1. Okay. Ooh, some big terms. All right. When your numbers are very big like this, you can look at it and say, can I factor something out before I factor by grouping? So maybe there is a common term, right? 21 and 84. I know those are both divisible by 7. Right? So I'm going to say, is 56 divisible by 7? It is. Is 224 divisible by 7? Hopefully 32. So what I can do first is take 7 out of everything. Divide that by 7. Divide that by 7. Divide that by 7. Divide that by 7. That's the only one I can divide it by because this has A, this has A, this doesn't have A. This has Z, this doesn't have Z. This has C, this doesn't have C. So only 7. So when I factor it out, I put it in front. Remember, we said 224 divided by 7 is 32 AZ. 56 divided by 7, we said was 8 AC. -84 divided by 7, we said was -12 ZY. Sorry, I started with the Z. And then -21 divided by 7 is a -3 YC. Hold on. Okay. Close those parentheses. So first I factored out the 7. Now this is more manageable, right? Now I can divide these into 2. So I have, and basically what you're going to do with that 7 is you're just going to put it out in front every time you bring things down, okay? So ignoring now the 7, we have a 32AZ and an 8AC. 32, can I divide it by 4? I can. 8, can I divide it by 4? I can. So I could pull out an 8 here, or sorry, a 4 here, right? I could pull out a 4 and it would be 8AZ plus 2AC, right? However, if I can pull out a 4, I might be able to pull out an 8. 32 divided by 8 is 4, and then 8 divided by 8 is 1. So you always want to pick the biggest term you possibly can, okay? Here it's going to be a positive 8. And then this is AZ and this is AC, so I can take out the A's. Good. 32AZ divided by 8A. We said 32 divided by 8 is 4. Sorry, again, 8A. 4Z, right? And then plus 8AC divided by 8A is just plus C. Let's look at the other side. We have a negative, okay? So this is going to be a minus whatever we're dividing it by. 12 and 3, I can divide them both by a 3. So it's a negative 3 because of that minus sign. ZY, YC, I'm going to take out the Y. So negative 3Y, okay? Negative 12 divided by negative 3 is a positive 4. Z. Negative 3 divided by negative 3 is a positive 1C, okay? Again, you have that same term. Don't forget the 7. So around all of this, we still have a 7, okay? We still have that same term. So we just take that, divide it by 4Z plus C, divide that by 4Z plus C. Good. Now, what I'm left with is 4Z plus C times 8A minus 3Y. Again, bring that 7 down. 7 times 4Z plus C times 8A plus 3Y. Good. So sometimes you'll be able to take something out and then factor it. Sometimes, like with the number 32 and 8, you can divide it by 4, but it's better to divide it by the biggest number you possibly can. You'll know that because if we divided by 4, you would get an 8 here and a 2 here, and you could say, oh, I can divide 8 and 2 by 2. So you'll know because you'll see another factor in there. Right. Here we have MZ minus 5MH squared. I can factor out an M. So M on the outside, Z minus 5H squared. Over here is a negative. So I'm going to factor out a negative 5N, negative 5N. So I have negative 5N, and then parentheses, negative 5 divided by negative 5 is just a 1. The N's come out, so I just have a Z or a 1Z. Positive 25 by negative 5 is a negative 5. 8 N's cancel. I have an H squared. So my final answer is Z minus 5H squared times M minus 5N. Good. All right, and our last one, 12xy minus 28x. I can divide them both by, let's see, can I take 28 divided by 12? No. 28 divided by 6? No. 28 divided by 4? Yes. So I know 4 goes into 12 and 28. I'm just going to say 4. 4, they both have x's, so I'm going to call it 4x. Okay. 4x is out in front. 12 divided by 4 is 3. 28 divided by 4, we said is 7, and it's a negative 7 because that was a minus. And then over here, negative 15 and positive 35. So we can negative 15y plus 35, we can take out a negative 5, negative 5. Negative 15y divided by negative 5 is just a positive 3y positive 35 by negative 5 is going to be a negative, and 35 divided by 5 is 7. So here we have 3y minus 7 times 4x minus 5.